What's up, Internet, and welcome back to this tutorial series. Today, as we continue building our little farming game here, we're going to look a little bit more at the actual tool interactions, how we can start planting seeds and kind of determining what we have to do on those seeds based on what tool is in the player's hand and stuff like that, and actually start thinking about how the plants will grow, managing the plant's life cycle, and kind of starting to get some actual game mechanics in our little game here. So, hopefully you're ready to start thinking like a game developer, and let's get going. So first things first, in order to actually determine what these tools do when you interact with something, we need a better way of defining what the tools actually are. Because right now, they basically just have a name and a graphic. And the problem is, these are not really things that are good for performing operations. So for example, if we look at tool name, basically we can put whatever we want inside of this string. And then, if we say tool name equals, let's just say bucket, trying to actually, if we're trying to say like make it an if statement, we're trying to like compare these two. Obviously this is not going to run because this is not bucket, but there's just a lot of places where you can kind of run in, create problems for yourself, make it easy to make mistakes. So like if we say bucket with a small b, this is not going to run. If we say, bucket with a space at the end, this is not going to run. There's just a lot of places for errors when it comes to things like string comparisons and using strings for operations. So generally a better approach is to use something called an enum. So if we make one at the top here real quick, now rather than storing something in a string, we can literally just say what is the tool type of this? We basically defined a new type of data when we create this tool type. So if we look at something like these other variables, these are all values that are stored in memory somewhere. Whereas this enum, it doesn't really have a stored value. It's more of like a definition where, like I said, we're creating a new type of value that we can use in order for our specific game for our specific purposes. So in order to have an actual value for this tool type, we need to make a new variable of the type tool type. And then just in general, it's a good practice to default it to none. And our variable actually needs a name. And so this is just a little bit more, we can still use this name variable. I think I'm probably just going to get rid of it just for the sake of confusion. But if we save and come back to our tools, now we can say that there's this little field here, and the only valid values that can go into this data is the ones that we set up in the code. So it should be very safe and very reliable. It's easy for us to pass this information around and understand how it works. We don't have to have any kind of like complex understanding of like the rules or anything like that. It's just these are the exact values it can be, and that it's reliable. So we just have to set this up for all of our tools now. Like it's just set for us. Okay. I guess Unity just did some cool smart stuff. I guess probably based on the name of our objects because it's using the same name. But now, if we come over to our player controller here, we can say whatever this held tool is, we can just say dot tool type, and start kind of figuring out what is in the player's hand and how we are going to do the things that tool is intended to do. But as far as actually kind of like processing what those interactions are and how they impact, the seed as it's in the ground and the plant location and stuff like that, we actually need to create what that plant location is. We need a new game object for that, kind of similar to how we made our player and our other tools down here. So let's do that. Let's just make a new game object, call it our plant location. Let's make sure it's in the middle. We know we want a sprite renderer for it because we need to draw what is actually in the ground and all this kind of stuff. But by default, this is kind of where we want it to start. So before we get too deep into setting up the plant location itself and how all those interactions start and stuff like that, let's kind of start making sure that the basics work. I mentioned how our plant location is going to kind of have to look at what tool is in the player's hand and kind of do operations based on that. So let's kind of start off by making sure that the player can interact with the plant location, the plant location can kind of detect what tool is in the player's hand. So let's start with there. It's probably safe to say that we're going to need a new script for this. And location. And much like how our tools use this onTrigger2D to process when the player interacts with the tool, we're going to take the same approach to understand how the player interacts, or when the player interacts with a plant location. And so in this interaction with the tool here, we kind of made sure that whatever we're colliding with, passed to us by this collision parameter, we want to make sure that it's a player, and in this case we want to do the same thing. You know, just to recap, the collision.gameObject, whatever touched the plant location is what is going to be stored within this collision.gameObject field. And then off of the game object, we want to get the component of our player controller and store that in this player variable. And then we want to make sure that whatever we interacted with, if it's not actually the player, then we don't want to do any actual operations on it. And in this case, similarly, we also want to get the tool that the player is currently holding. So now that we know that the player is valid and is not going to be null, we can look at what is in the player's hand and just ask it. Well, ask the player. Say, what are you holding in your hand here? This value, I've made it private. The tool that the player is holding is a value that only the player really knows, and the idea is that the player should be the one who is managing what they're holding. We can ask the player what they're holding using this get function, but generally we don't want other places in code to be the ones that set the player what they're holding. So once we ask the player what was being held, let's just, for now, let's just say, just output the tool.toolType. And ideally that should work, but we are still missing one other thing, and that is the fact that there's no way for this collision to actually occur yet. If we looked at our tools here, we see that there's a box collider 2D, and that's kind of looking for the player to overlap with this box here, but we don't have that on our plant yet. So we also need not a box collider, but a box collider 2D, and we want it to be a trigger. I think that at that point, that should let us test our tools. So if we grab a bucket, it says bucket. If we grab a scythe, it says scythe. Okay, cool. I mean, we had that functionality working before, but now we're just kind of calling this debug from a different place, so we know that it's not the tool. This is where we had it before. The tool was the one telling, or no, it was the player, I think, was telling us that it knew what tool the player was holding, and now we're just seeing, okay, the plant location knows what tool the player is holding as well. However, if we note, you see how I have this little protection here, this code to make sure that the player isn't null before operating on it? We don't have something for the tool, so let's just demonstrate what that does real quick. You can see that with nothing in our hand, basically if we come into this code and say, okay, we've got a valid player, what is the player holding? We store this value. We're asking the player what is the held tool, but it starts at null, and this null value isn't set until the player actually interacts with one of the tools. So when we come to the plant location, if there's nothing in the player's hand, this tool value is going to be null, and so if we try and use one of the values that's held within it, there is no value for the code to get. And so it gives us an error, a null reference exception. And that would generally crash the game and is bad. And so that's why we have these kind of protections here. So in the same way, if there's no value in the held tool, then we also want to return in that case as well. And then that will prevent the crash, the error from actually happening, and it'll just kind of ignore everything and just kind of exit this function. And now we can kind of say that if we get this far in the code, then we know it's safe to kind of look at the player, we know it's safe to look at the tool in their hands, and we can kind of start saying, okay, what are we doing at this plant location based on the tool on the player's hand? Are we doing anything? However, what happens is determined by more than what's just in the player's hand. So for example, if we had this location here, and if we say we planted a seed, and it already looked like this, and it was growing, we don't want to be able to plant another seed on top of it, right? We don't want to be able to water a location that is empty. We don't want to be able to harvest a seed that isn't ready, these kind of things. And so in order to make sure we're doing the right interactions, we also need to know what state the actual plant is in its life cycle. A very complex version of this concept is what you might call a state machine, but for us, we're going to keep it fairly simple. Similar to how we used this enum for our tool controller, we need another enum for our plant to be able to track the states. And so kind of similar to how, if we look at our tools here, these things that we defined in our enum are the only valid states of this tool type variable. These states are the only valid states that our plant can exist in. And so now we can kind of say, if the plant is unplanted, if there's nothing in the ground already, that's when we can use our seed tools to plant seeds in the ground. If our plant is growing, we don't want to do that, but that's when maybe we want to worry about using our water bucket and stuff like that. If our plant is harvestable, that's when we want to care about using our scythe. And so now down here, we can kind of start thinking about what these actual conditions are. And a good way of doing this is using a switch statement. Basically, a switch is kind of like a version of an if, but the idea is if you're using a switch, usually you're kind of looking at all the possible states within the variable that you're switching are on. So in this case, it would be our plant state, which we need to store in an actual variable. And we probably want to start at unplanted. Okay. But by default, it will be unplanted, so we can say in here, in our switch, what are the cases we're looking for? Basically, if our current state is this unplanted state, then it's going to come in here and run this code. Break is just kind of saying, this is the end of this code chunk. So now we can just kind of put our actual functionality in here, and it'll kind of, depending on what state the plant is in, it'll give us the interactions we need. So, vaguely, if we just write this out quickly in some comments, just to kind of make sense of the code, say, if we are holding a seed, plant it in the growing section here, check for watering logic, and in here, this is kind of how we're going to manage our plant as it's kind of in this location. So now we're kind of ready to start making these actual interactions, but before we can do that, we need our actual graphics so we can kind of communicate those interactions to the player and kind of make sure that they understand what's happening, but also for our own purposes, make sure that we can visualize the cycle as it's going so we can kind of debug our code and make sure that it's working as well. To recap real quick, if we look at our plant graphics here, basically the idea that we said is that we have 3 final potential seeds. We have pumpkins, cabbages, and carrots. And then, the idea is you plant the seed, it starts in this unplanted state, and then as you water it, it kind of grows and eventually turns into one of these final seeds. So we're going to need to have references to all these graphics so that we can update the image in our sprite renderer here as the plant progresses. So if it starts here, then we water it a little bit more, water it a little bit more, and then eventually it's harvestable. It is the final plant and we're good to go. So in order to actually set the value of our sprite renderer, we're obviously going to need a reference to that, and then we're going to need the images that we're setting to that value so that we can do that programmatically as the game progresses, as the plant cycle continues. So we've got a reference for our sprite renderer. We've got a reference to our actual image graphics. Now we just have to kind of set up the references on our actual object here. So if we look at our plant location script, the sprite renderer is one that we can just grab in. And in fact, a good practice here for something like this, where we know the sprite renderer is going to be on the same game object as our plant location, just to make sure that we're not kind of relying on the status of this data connection, one thing we can do is, if we don't have a connection set up in data yet, then we can try and just get it. So now we see this code is, so this is our start function. So as soon as you press play, basically, as soon as this game object is created in the world, this code is going to run. And so with this code, even if we don't set this value, in fact, let's just demonstrate. If this value is clear when we click run, then we can see that even without this being set by default, this code kind of came in here and automatically grabbed the sprite renderer. So if you're relying on these components for your code to function, it's an option that's sometimes that's a good approach to take for some types of objects. But anyways, let's just start with our final graphics here. Okay, cabbage carrot. And let's set this back to this kind of unfilled graphic just so we can kind of test. And now that we have these references in code, we can kind of start doing things with these graphics. So for example, if we come in here and we say, the player is holding seed 1, and we can get the sprite renderer, set the value of the graphic to, we're saying seed 1 is the pumpkin, I guess. Let's just test this out real quick. Seed 2, seed 3, cabbage is 2, I think, and then carrot. And so now what this should do is, if there's nothing planted in the spot in the ground, if the player is holding one of the seed things, then it should change the graphic displayed in the sprite renderer here to the appropriate value for what the seed the player is holding is. So if they're holding the pumpkin seed, it should update this to look like the pumpkin. If they're holding the cabbage seed, it should update this to look like the cabbage. See, it goes pumpkin. Oh, I've got the carrot with the cabbage. So there's an issue there, but we can see that depending on what tool we're holding, it'll have different interactions, and then if we equip the side, it doesn't do anything. So we're making progress, huzzah! I guess I need to fix these up real quick. I need to switch the cabbage and the carrot around. And yeah, before we go too much further, there is a little bit that I want to clean up in our code here. And first off, if we look at our enum here that we're using to determine what kind of tool the player is holding, we can see that it's looking at the tool controller.tooltype.seed. And this is a little bit awkward because ultimately what we've done is we've created a scenario where the enum lives within the tool controller, but the plant location relies on this information in order for it to function. So every time the plant location needs to look at this information, it needs to ask the tool what even is a tool, basically. Like, the plant location has no idea what any of these things mean, so it kind of has to defer to the tool controller. And so in a situation like this, where both the tool controller and the plant location rely on this information, oftentimes it's better to kind of put it in a separate place where we can kind of manage all these values together. So a way to do this is we create a new script. I'm going to call it global. And basically, this is going to be a little bit of a different type of script. This isn't something that we're going to attach on a game object or anything like this, but instead, we're basically just going to take this value here, this tool type, and move it into global. I think we want it to be outside of the class definition. And so basically, by putting it here, the tool type should still be visible to everybody, so we can see that our tool controller still knows what a tool type is. And if we come into our plant location, Now, our plant location also knows what a tool type is by default, and we don't need to ask the tool controller anymore. And I guess I will say, just right from the very start, this kind of approach of using the kind of like global class in order to hold your variables and stuff like that is a little bit dangerous. It is a little bit risky. Generally, you want objects to all be kind of managing themselves and kind of have the information they need about themselves and not rely on external sources for it, not store that information in external places. But I talked a little bit earlier about how an enum definition like this isn't actually a stored value. It's actually more of like just a declaration of like a type. And so this is a little bit safer to kind of put in another code file externally because, like I said, a lot of different types of objects are going to care about what this value is, but there's never going to be a place where they're like kind of like setting values. Like maybe you have one class that's setting a value and then another class is kind of reading that value, and things can kind of get out of order and out of sync. This value is effectively read only, and so there isn't really any danger of kind of like if a million different places are reading this value all at the same time, they're never going to mess with each other. It's never going to create a problem. So this is relatively safe. And then the other thing I want to do is kind of like clean up this a little bit. So similarly to how you kind of want objects to kind of like be maintaining their thing, generally for a function you kind of want it to have one purpose and do that one purpose well. And if there's other things that need to be handled within the function, you kind of pass it off to another function that is kind of more capable, that's more designed to do that one specific thing. So our trigger enter 2D here is kind of detecting when interactions happen, kind of determining what those interactions should be. But rather than processing these interactions in the code here, we more or less want to move those interactions somewhere else where it's a little bit cleaner. And we don't need to kind of like read through all of this and this at the same time. We can kind of, it's called separation of interest, basically making sure one thing works, making sure the other thing works, and because if they're intertwined and doing things in the same place, it can be very kind of hard to read and kind of follow and stuff like that. So we can kind of make our planting functionality a little bit cleaner just by separating it out. Rather than having all these different things like this, we can simply say, if we handle all of our actual planting logic in here, we can kind of take these, simply say, plant whatever seed 1 is, plant whatever seed 2 is. Whatever it is, whatever seed the player is holding in their hand, just plant it, and whatever operations we need to do depending on what the seed actually is, we can do down here. So at the moment, we'll clean this up more as we go, but at the moment we do need this kind of if tree again, because we need our sprite renderer to draw the graphic depending on what seed we're drawing still. So now this is effectively doing the same thing, but this code is like very solid, and we probably don't have to look at it very much at all in the future, whereas our actual operations of what happens when planting a seed happens is all going to be down here, and we can just kind of worry about it down here. So for example, when we do plant a seed, we know that we don't want to be in this unplanted state anymore. So at that point, we want our current state to become growing. And so now that all this planting functionality is kind of like separated out into its own place, it's not the cleanest code at the moment. We have a better approach than using this if tree, since we have this if done here. We don't need to do it in both places ultimately. But this planting code will be a lot easier to expand, a lot easier to kind of look at and read and understand now that it's separated. And we can see that now that we are actually advancing our state when we plant the seed, no matter what seed we plant, we grab a seed and then plant it. We can plant the pumpkin. We grab another seed and walk over top of it. Now nothing happens because we know that our plant is already in the growing state. So now when we walk over top of it, when we create an interaction, this code is going to come in here and say, okay, our plant is in, what state is it? Oh, well, it's not in unplanted, so none of this is going to happen. It's in growing. So what's happening? Nothing is happening in growing event at the moment. This is functionality that we're going to have to add as we keep going. You know, ultimately, we don't actually want to start off by planting these graphics. Like, these are our final graphics. Oh, actually, this is wrong. Okay, well, these are our final graphics. We're kind of using these as our starting place right now as kind of like a debug so we can see what we're doing. But ultimately, we don't want to start there. When we plant a seed, there's actually a different starting place for it, right? So we want to start with this guy and then go to this guy and this guy and then this guy and then pumpkin or cabbage or carrot. And I think we'll get into the actual setting up that life cycle and watering the plants and all that stuff next time. But for now, we can at least start kind of figuring out getting those assets set up. So similar to how we have our final assets for our pumpkins, our cabbage, our carrot, we need references to these kind of growing graphics, this kind of sequence that we talked about. So we need to store these as well, and we can do that in an array. So by putting these two square bracers here, we're basically saying that similar to how we store this pumpkin graphic in this variable here, this growing graphics variable holds a sequence of values. And so if we come over to our location here, we have our new field for growing graphics, and right now it says the list is empty. And basically we have to tell it how many values it's going to hold. And then this is basically our sequence. So we can say that the first value in this array is going to be our empty graphic. Our second value is going to be this little sprout. Our third is going to be this little bigger one. Fourth is going to be this mostly full plant. And then this is the sequence is going to grow through as the plant grows. So we'll start setting up that actual life cycle in the next episode. I know this one was a little bit dry and there's a lot of setup in this episode, but now that we have a lot of these kind of basic building blocks and we have a lot of our kind of like states and stuff like that set up, we can start building all the interactions, and things are going to start moving very quickly as we kind of continue going in this series. But yeah, I hope that for now you kind of learned something you enjoyed, and you're kind of starting to get the feeling of how to think like a game developer and how to kind of like separate out objects and making sure they're all doing their own little job. And yeah, if not, don't worry about it. We'll keep going, we'll keep learning, and I'll catch you in the next one. If you enjoyed, like and subscribe, and see you later.